In software testing, there is a persistent divide between business intent and technical execution. On one side are the plain text requirements detailing how a feature should behave. On the other is the dense wall of Java automation scripts required to actually test it. This creates a hard communication boundary. Business analysts, scrum masters, and manual testers define the logic, while automation engineers handle the implementation. Because these groups operate in different formats, they often work in isolation. As automation suites grow, the underlying code becomes increasingly complex. The stakeholders who designed the initial business logic lose the ability to read, review, or contribute to the automated test cases. When the actual test conditions are buried under layers of technical syntax, the quality assurance process loses the direct oversight of the business domain experts. This technical isolation restricts cross-functional collaboration. When engineers and stakeholders cannot verify the same documentation, the Agile process stalls at the testing phase. Behavior-driven development, or BDD, is a methodology designed to repair this gap. It proposes that software behavior should be specified in a language both humans and machines can interpret. Cucumber is the specific architectural framework that implements this BDD methodology. It acts as a dedicated translation layer, taking plain English business logic and converting it into executable code. This connection allows two separate workflows, business specification and technical execution, to function as a single synchronized unit. To see exactly how this architecture operates, we will trace a standard software logging module from its initial concept through the framework's execution pipeline. Mastering this translation layer integrates testing directly into the business workflow, moving it out of the engineering silo and into a shared workspace. Implementing the Cucumber framework begins with a standard dependency deployment. We download the necessary libraries from the Maven repository and update the project's pom.xml configuration file to receive these new Cucumber dependencies. Once we reload the project to fully integrate these libraries into the codebase, the framework establishes a three-part architecture. The system is built on three specific components: feature files, step definitions, and test runners. These three pillars are tightly coupled. They must be constructed and operate in an exact sequence to function. Without this precise three-part dependency structure, the framework has no mechanism to link plain text to the back-end execution. The first architectural pillar is the feature file. This serves as the primary interface for non-technical team members. Inside this file, tests are formatted using Gherkin syntax. We define the high-level module, such as feature, login module, and then outline specific test cases, like scenario, valid login. The logic flow is controlled by specific keywords, given, when, and then. This syntax serves a dual purpose. It acts as both the official business requirement and the active test case. Because the syntax is written in simple English, Scrum Masters and manual testers can author these files directly without writing code. The feature file architecture also supports data-driven testing. Variables can be passed directly through the English text to test multiple permutations. We can inject explicit strings like root and chair, or pass numeric parameters like 100 and 200. Embedding these parameters directly prevents the need to write repetitive test cases for different user inputs. The feature file allows non-technical contributors to generate the primary test logic, which the system converts into structured data inputs for the backend. The second architectural pillar is the step definition file. This is where the automation engineer works. While the feature file provides the interface, the step definition is the engine room where the execution code resides. This illustrates the core operational mechanism, a strict mapping between the Gherkin sentence on the left and the back-end Java function on the right. Every single step authored in the feature file must have a corresponding automated block in this step definition file. This one-to-one mapping ensures the framework knows exactly what code to execute when it reads a specific English phrase. This layer also handles broader framework integrations, leveraging models like the page object model to ensure the code remains reusable across multiple tests. Step definitions isolate the engineering complexity, preserving execution power without cluttering the readable front-end interface. The final architectural pillar is the test runner. Having executable tests is only half the battle. We need a central controller to orchestrate when and how they run. The test runner specifies exactly which feature files are targeted for a run. It can categorize and filter these cases using groups and flags. All of these execution settings and scope parameters are defined through the Cucumber options block within the file. The test runner provides the administrative oversight required to deploy multiple test cases synchronously. With the components established, we can see the complete data flow of a test run from start to finish. The logic originates in the feature file, triggers the bound code in the step definition, and is routed through the test runner. This creates a significant reusability advantage. A single step definition can be triggered by dozens of different feature scenarios. Injecting data-driven parameters allows these dynamic values to cycle through this execution flow at high speed. The system's value lies in its ability to execute programmatic complexity using simple, text-based inputs. Once an execution cycle is complete, the test runner generates the final deliverable. It generates structured HTML test reports that clearly indicate test successes and failures, flagging specific scenarios like valid login and logout. These reports embed the original plain English Gherkin steps directly into the results matrix. This visual formatting allows a business analyst or Scrum Master to review test failures instantly, without needing to analyze back-end console errors. By returning results in the same language they were written in, the Cucumber architecture closes the communication loop. It proves that technical automation and accessible business logic can operate as a single unified system.